Here's something that sounds like a rejected movie pitch. A fully operational data center sitting on the ocean floor cooled entirely by seawater, generating power almost entirely from wind turbines spinning above it. That's not science fiction. It went live off the coast of Shanghai earlier this year, and it exists because of a project Microsoft actually tried first and gave up on. Back in 2014, Microsoft engineers sealed a data center inside a pressurized steel capsule and sank it into the Pacific Ocean, testing a simple idea. Since data centers generate enormous heat and need constant cooling, why not let the ocean do that job for free? They expanded the test in 2018, dropping a larger capsule off Scotland's Orkney Islands, packed with 855 servers. It worked. Server failure rates were actually lower underwater than on land, likely because there were no humans around bumping equipment or introducing dust and vibration. And in 2025, Microsoft quietly confirmed it was walking away from the entire project. Not because the engineering failed, because the economics didn't add up at Microsoft's scale. China took the exact same idea and made it commercially profitable. By the end of this video, you'll understand how a Silicon Valley giant with virtually unlimited engineering resources concluded this wasn't worth pursuing, how China reached the opposite conclusion, and where the real risk in this approach is still sitting largely unexamined. The core physics here is refreshingly simple. Every data center generates massive heat from thousands of servers running around the clock, and cooling that heat away typically consumes as much electricity as running the servers themselves, sometimes more. Land-based data centers usually solve this with industrial air conditioning, or more recently, by spraying enormous volumes of fresh, drinkable water through cooling towers. A single large hyperscale facility can consume millions of gallons of water a day, competing directly with nearby homes and farms for the same water supply. That competition for water isn't hypothetical. Major American tech companies have publicly disclosed billions of gallons of water usage annually just for data center cooling. And in drought-prone regions of the American Southwest, several proposed data center projects have run into direct local opposition specifically over freshwater consumption. This isn't a distant, abstract sustainability talking point. It's already a real permitting fight happening in American communities right now. The ocean floor solves both problems at once. Seawater sits at a stable, cool temperature year-round and is essentially free and limitless as a cooling medium. Submerge the server capsule, pump seawater across the back of the racks instead of through them, and the ocean carries the heat away continuously with no pumps working overtime, no water tower evaporating thousands of gallons a day, and no air conditioning compressors running non-stop. China's first real-world proof of this came from a facility off Hainan Island, developed by a company called HiCloud, first deployed commercially back in 2023. The setup is almost absurdly heavy-duty. A sealed pressurized capsule weighing 1,300 tons, roughly the weight of 1,000 passenger cars, lowered 115 feet to the ocean floor. Each capsule holds 24 server racks, somewhere between 400 and 500 servers, and by pulling cooling directly from the surrounding seawater, the facility runs about 40 to 60% more power efficient than an equivalent land-based data center. Getting a 1,300-ton sealed capsule from a factory floor onto the seabed isn't a simple engineering footnote either. Each module is assembled and pressure tested on land, transported by specialized barge to the deployment site, and then lowered on cables over roughly 3 hours to reach the ocean floor without damaging the sensitive equipment sealed inside. Every capsule is engineered for an operational lifespan of about 25 years before it needs to be retrieved for major servicing. The results after roughly 3 years of continuous operation are the part that should genuinely surprise people. Reported near-zero server failures and no on-site maintenance required at all. Combined computing capacity across the Hainan cluster is now estimated at the equivalent of 30,000 high-end gaming PCs running simultaneously, and a recently added module alone can process 7,000 AI chatbot queries every second. This wasn't a one-time stunt either. China's official 5-year development plan for Hainan calls for scaling this single site up to 100 underwater capsules total, an underwater data center campus, effectively built one sealed module at a time. That scale matters because of timing. Global AI computing demand has been roughly doubling year over year, and every major AI lab on the planet is racing to secure more server capacity, not less. A cooling and power strategy that looked like a nice-to-have 5 years ago is quickly becoming the difference between a company that can actually build the capacity it needs and one stuck waiting years for land, water permits, and grid connections that may never fully materialize. And that's before the project that actually pushed this technology past where even Hainan had taken it. Stick around, because what happened next off the coast of Shanghai earlier this year is the part that should really make American cloud providers uncomfortable. And if you find stories like this interesting, now's a good time to hit subscribe. In the spring of 2026, China switched on a second underwater data center, this time near Shanghai's Lingang district. And this one solves a problem the Hainan facility never fully addressed. Where does all that electricity actually come from? The Lingang facility sits surrounded by more than 50 offshore wind turbines, drawing roughly 95% of its power directly from that wind farm. It's a smaller installation than Hainan, housing around 2,000 servers with 24 megawatts of total capacity. But the design target is much more ambitious. A 500 megawatt version is already planned as the next phase. The project carries a price tag of roughly $226 million, and according to the company that built it, the engineering directly reuses lessons learned from 3 years of running the Hainan site, including that same track record of essentially zero unplanned maintenance trips. Running 2 of these facilities in 2 different regions with 2 different power strategies isn't a company hedging its bets on an experimental idea anymore. It's a company scaling a business it's already confident works. The efficiency numbers on this one are genuinely remarkable. The facility reports a power usage effectiveness rating of 1.15 or better. For context, China's own national efficiency target for large data centers by 2025 was 1.25, and this facility is already beating that goal by a meaningful margin. It also essentially eliminates freshwater consumption entirely and cuts land use for the facility by more than 90% compared to a traditional data center with equivalent capacity. Put bluntly, this is a data center that barely touches the freshwater supply, barely touches the power grid beyond its own dedicated wind farm, and barely touches the land at all. That's 3 of the biggest political and environmental headaches in modern data center construction, addressed simultaneously by putting the whole problem underwater. Now here's the honest risk that gets glossed over in most coverage of this technology, and it's a real one. When something breaks on a land-based server rack, a technician walks in, swaps the part, and walks out the same day. When something breaks inside a sealed capsule sitting 115 feet underwater, the fix potentially means hauling an entire 1,300-ton module back up to the surface. These systems are engineered for extremely long service intervals, specifically because unscheduled maintenance is so much harder to pull off. But harder isn't the same as impossible, and a serious hardware failure between scheduled retrievals could mean real downtime with no quick fix available. There's also a genuine, still unresolved environmental question. These capsules pull in cool water and release slightly warmer water back into the ocean continuously. Researchers have found that this kind of localized thermal discharge at scale can measurably shift oxygen levels and marine life patterns in the surrounding water. China has stated it's monitoring conditions around the Hainan site, but multi-decade environmental data on ocean floors covered in heat, generating server clusters simply doesn't exist yet anywhere in the world because nobody has operated equipment like this at this depth and this scale before. It's worth noting that American cloud providers aren't simply ignoring this problem. They're just betting on different fixes. Advanced liquid cooling systems, next-generation heat exchange designs, and even proposals to move future data centers into orbit have all attracted serious investment from US companies over the past couple of years. Underwater deployment isn't the only possible answer to the same underlying problem. It's simply the one China decided to actually commercialize first, while other approaches are still mostly in earlier testing phases. So, what actually broke here? Not the engineering. Microsoft already proved this could work technically over a decade of testing. What broke is Microsoft's underlying business assumption that hauling terabytes of steel and silicon into the ocean was a clever engineering trick, but not something worth doing at commercial scale when land-based data centers, however wasteful with water and power, were still the cheaper and simpler default. China ran a different calculation, one where fresh water, land, and grid power are treated as the actual scarce resources worth protecting. And once that calculation started paying off commercially, harder to build, stopped being a good enough reason to stay on land.